Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive Git and GitHub tutorial. This will be a hands-on guide with explanations and practical examples. We'll cover everything from basic Git concepts to collaborating with others on GitHub. Table of Contents *. 1. Introduction to version control and Git. 2. Installing Git. 3. Basic Git configuration. 4. Essential Git commands, local repository. 5. Understanding the Git workflow. 6. Branching and merging. 7. Undoing changes. 8. Introduction to GitHub. 9. Connecting local and remote repositories, GitHub. 10. Working with remote repositories, GitHub. 11. Pull requests and collaboration. 12. Resolving conflicts. 13. Ignoring files, gitignore. 14. Stashing changes. 15. Advanced Git concepts, brief overview. 16. Practical examples and scenarios. 17. Tips and best practices. 18. Troubleshooting common issues. 1. Introduction to version control and Git. What is version control? Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. It allows you to track changes to your code. Revert to previous versions. Collaborate with others efficiently. Experiment without fear of breaking things. Identify who made what changes and when. Why use version control? Collaboration. Multiple developers can work on the same project simultaneously without overriding each other's work. Backup and recovery. If something goes wrong, you can easily revert to a previous working version. Experimentation. Create branches to try out new features or bug fixes without affecting the main code base. Auditing. Track changes and understand the evolution of your project. Git, the distributed version control system. Git is a widely used distributed version control system. Distributed means that every developer has a complete copy of the repository, including the entire history, on their local machine. This allows for offline work and faster operations. 2. Installing Git. You'll need to install Git on your system. Here are instructions for different operating systems. Windows. Download the latest Git for Windows installer from https://gitscm.com/download/win, https://git-scm.com/download/win. Run the installer and follow the on-screen instructions. Accept the default options in most cases. During the installation, you'll be prompted to choose an editor. If you're not familiar with command line editors like Vim or Nano, choose a GUI editor like Notepad++, if installed, or let Git Bash use its default. Make sure you select the option to use Git from the Windows command prompt to make it easier to use Git from any terminal. Mac OS Option 1, recommended, using Homebrew. If you have Homebrew installed, run. Option 2, using Git installer. Download the installer from https://gitscm.com/download/mac, https://git-scm.com/download/mac, and follow the instructions. Linux, Debian/Ubuntu. Linux, Fedora/CentOS. After installation, verify that Git is installed correctly by opening a terminal or command prompt and running. You should see the Git version number printed. 3. Basic Git configuration. Before using Git, you need to configure your identity. This information is used to identify you as the author of commits. Replace your name and your .email at example.com with your actual name and email address. The -global flag means these settings will apply to all your Git repositories on your system. You can also configure your preferred text editor for Git. Choose the editor you're most comfortable with. Code will open Visual Studio Code. Nano is a simple command line editor. You can view your Git configuration by running 4. Essential Git commands, local repository. *git init * initializes a new Git repository in the current directory. This creates a .git subdirectory, which contains the repository's metadata. *git status * shows the status of your working directory and staging area. It tells you which files have been modified, which are staged for commit, and which are untracked. You'll see that readme.md is untracked. *git add * adds files to the staging area, index. The staging area is where you prepare changes to be included in the next commit. Now readme.md should be staged for commit. *git commit * creates a snapshot of the changes in the staging area and saves it to the repository's history. You must include a descriptive message with your commit. The M flag allows you to specify the commit message directly on the command line. *git log * shows the commit history of the repository. You'll see a list of commits, each with a unique SHA-1 hash, author, date, and commit message. *git diff * shows the differences between files in your working directory, staging area, and the last commit. *git diff shows changes in your working directory that are not staged. *git diff staged shows changes that are staged for commit. *git diff head shows all changes since the last commit, working directory and staged. You'll see the lines that were added to readme.md. *git rm * removes files from your working directory and the staging area. You'll need to commit the removal to make it permanent in the repository's history. *git mv * renames or moves files. 5. Understanding the Git workflow. The typical Git workflow involves the following steps. 1. Modify files * make changes to your code or other files in your working directory. 2. Stage changes * use git add to add the changes you want to include in your next commit to the staging area. 3. Commit changes * use git commit to create a snapshot of the staged changes and save them to the repository's history. 4. Repeat * continue modifying, staging, and committing changes as you work on your project. 6. Branching and merging. What is branching? Branching allows you to create separate lines of development within your repository. This is essential for working on new features, bug fixes, or experiments without affecting the main code base. *git branch * lists, creates, or deletes branches. *git branch lists all local branches. The current branch is marked with an asterisk. *git branch _name creates a new branch named branch _name. *git branch d branch _name deletes a branch named branch _name. Use d to force deletion if the branch hasn't been merged. *git checkout switches between branches. *git checkout branch _name switches to the branch named branch _name. *git checkout b branch _name creates a new branch named branch _name and switches to it. *git merge merges the changes from one branch into another. If there are no conflicts, Git will automatically merge the changes. Example *. 7. Undoing changes. *git checkout file * discards changes in your working directory. This will revert the file to the state it was in the last commit. Use with caution, changes are lost. *git reset head file *unstages a file that has been added to the staging area. Introduction.md will be removed from the staging area. *git commit amend modifies the last commit. This is useful for correcting mistakes in the commit message or adding forgotten changes. Important note: never amend commits that have been pushed to a shared remote repository, as it can cause problems for other collaborators. *git revert commit creates a new commit that undoes the changes introduced by the specified commit. This is the preferred way to undo changes in a shared repository because it preserves the commit history. 8. Introduction to GitHub. What is GitHub? GitHub is a web-based platform that provides hosting for Git repositories, along with collaboration features like issue tracking, pull requests, and code review. It's essentially a social network for developers. Why use GitHub? Remote repository hosting provides a central location to store your code and collaborate with others. Collaboration tools offers features like pull requests, issue tracking, and code review to streamline the development process. Open source community hosts a vast amount of open source projects, making it easy to discover and contribute to them. Version control management simplifies the process of managing and tracking changes to your code. Creating a GitHub account go to https://github.com/ https://github.com, and sign up for a free account. 9. Connecting local and remote repositories, GitHub. Creating a remote repository on GitHub. 1. Log into your GitHub account. 2. Click the plus button in the upper right corner and select New Repository. 3. Give your repository a name, example My Project. 4. Choose whether it should be public or private. 5. You can optionally add a README file, but you can also do this later. 6. Click Create Repository. Connecting a local repository to a remote repository. 1. Copy the remote repository URL from your GitHub repository page. It will look something like git@github.com, your username /myproject.git, or https://github.com/ your username /myproject.git. 2. In your local repository, add the remote using the git remote add command. Origin is a common alias for the remote repository. You can use a different name if you prefer. Git remote v shows the remote repositories that your local repository is connected to. You should see origin listed, along with its fetch and push URLs. 10. Working with remote repositories, GitHub. Git push uploads your local commits to the remote repository. The first time you push to a new branch on the remote repository, you may need to use the U flag to set the upstream branch. After that, you can simply use git push. Git pull downloads changes from the remote repository and merges them into your local branch. It's important to pull regularly to stay up to date with the latest changes made by other collaborators. Git clone creates a local copy of a remote repository. This creates a new directory with the same name as the repository and initializes a Git repository inside it. Git fetch downloads objects and refs from another repository. Unlike git pull, git fetch does not automatically merge the changes into your local branch. You need to explicitly merge them using git merge. Git fetch is useful for reviewing changes before merging them. 11. Pull requests and collaboration. What is a pull request? A pull request, PR, is a way to propose changes from a branch in your repository, or a fork, to another branch, usually main. It allows other collaborators to review your code, provide feedback, and discuss the changes before they are merged into the main code base. Creating a pull request. 1. Create a branch for your changes, example feature/new feature. 2. Make your changes, commit them, and push the branch to your remote repository. 3. Go to your repository on GitHub. 4. You should see a banner suggesting you create a pull request for your newly pushed branch. Click the Compare and Pull Request button. 5. Fill in the pull request details. Base branch the branch you want to merge your changes into, usually main. Compare branch the branch containing your changes. Title a descriptive title for your pull request. Description a detailed explanation of the changes you've made and why. 6. Click Create Pull Request. Reviewing a pull request. 1. Click on a pull request in your GitHub repository. 2. Review the changes made in the pull request. 3. Add comments to specific lines of code or to the pull request in general, providing feedback and suggestions. 4. Approve the pull request, if you're a maintainer and the changes are acceptable. Merging a pull request. 1. If you have the necessary permissions, example you're a maintainer, you can merge the pull request. 2. Click the Merge Pull Request button. 3. Confirm the merge. 4. Optionally, delete the branch that was used for the pull request. 12. Resolving conflicts. What are conflicts? Conflicts occur when Git cannot automatically merge changes from different branches. This usually happens when the same lines of code have been modified in different branches. Identifying conflicts. When you try to merge a branch with conflicts, Git will print an error message indicating the conflicted files. The conflicted files will contain special markers indicating the conflicting changes. Resolving conflicts. 1. Open the conflicted file in your text editor. 2. Carefully examine the conflicting changes. 3. Decide which changes to keep, modify, or combine. 4. Remove the conflict markers, ==============================================================================================================================::::::::::് 6. Git add file. 7. Commit the resolved changes, git commit m resolved merge conflicts. Example. Let's say you have a conflict in introduction.md. You might decide to keep both versions, but with a slight modification. Then, remove the conflict markers, save the file, stage it, and commit it. 13. Ignoring files, gitignore. What is gitignore? A gitignore file specifies intentionally untracked files that Git should ignore. This is useful for excluding files that are specific to your local development environment, temporary files, or sensitive data, like API keys. Creating a gitignore file. 1. Create a file named gitignore in the root directory of your repository. 2. List the files and patterns you want to ignore, 1 per line. Common gitignore entries. *star.log, ignore all files with the .log extension. */build, ignore the build directory and its contents. *node_modules/, ignore the node_modules directory, common in node.js projects. *config.ini, ignore the config.ini file. *star.swp, ignore swap files created by Vim. Example.gitignore*. Testing your gitignore*. You can use git gitignore v file to check if a file is being ignored. It will tell you which line in the .gitignore file is causing the file to be ignored. 14. Stashing changes. What is stashing? Stashing allows you to temporarily save changes in your working directory without committing them. This is useful when you need to switch branches or pull changes from the remote repository, but you're not ready to commit your current work. *git stash * saves your uncommitted changes. This saves your changes to a stash and reverts your working directory to the state of the last commit. *git stash list * lists all stashed changes. You'll see a list of stashes, each with an index, example stash at 0. *git stash apply * applies a stashed change. This applies the changes from the specified stash to your working directory. The stash remains in the stash list. *git stash pop * applies a stashed change and removes it from the stash list. *git stash drop * removes a specific stash from the stash list. *git stash clear * removes all stashes from the stash list. 15. Advanced Git concepts, brief overview. Rebusing * an alternative to merging that rewrites the commit history. Use with caution, especially in shared repositories. *hooks * scripts that run automatically before or after certain Git events, example commit, push. *submodules * allow you to include another Git repository as a subdirectory within your repository. *subtrees * similar to submodules, but simpler to use in some cases. They merge another project's history into your project's history. *git lfs, large file storage for managing large files, example images, videos, in your Git repository. Interactive staging, git add p allows you to stage specific parts of a file instead of the entire file. 16. Practical examples and scenarios. Scenario 1, Bug Fix. 1. You discover a bug in the main branch. 2. Create a new branch for the bug fix, git checkout b bug fix /fix login error. 3. Fix the bug. 4. Commit the changes, git commit m fixed login error. 5. Push the branch to the remote repository, git push origin bug fix /fix login error. 6. Create a pull request on GitHub. 7. After review and approval, merge the pull request into the main branch. 8. Delete the bug fix branch, git branch debug fix /fix login error. Scenario 2, Feature Development. 1. You want to add a new feature to your project. 2. Create a new branch for the feature, git checkout b feature /new search bar. 3. Develop the new feature, making multiple commits as you go. 4. Push the branch to the remote repository, git push origin feature /new search bar. 5. Create a pull request on GitHub. 6. Collaborate with other developers, addressing feedback and making necessary changes. 7. After the feature is complete and approved, merge the pull request into the main branch. 8. Delete the feature branch, git branch d feature /new search bar. Scenario 3, Contributing to an open source project. 1. Fork the repository on GitHub. 2. Clone your fork to your local machine, git clone git at github.com your username /project name.git. 3. Create a new branch for your contribution, git checkout b feature /improve documentation. 4. Make your changes and commit them. 5. Push the branch to your fork, git push origin feature /improve documentation. 6. Create a pull request from your branch to the original repository's main branch. 17. Tips and best practices. Write clear commit messages. Use descriptive commit messages to explain the changes you've made. Follow the imperative mood, example add feature, fix bug, refactor code. A good commit message has a short summary line, less than 50 characters, followed by a more detailed explanation, optional. Asterisk commit frequently asterisk make small, focused commits. This makes it easier to understand the history of your project and to revert changes if necessary. Asterisk pull regularly asterisk pull changes from the remote repository frequently to stay up to date with the latest changes. Asterisk use branches effectively asterisk use branches for all new features, bug fixes, and experiments. This helps keep your main branch stable. Asterisk code review asterisk have other developers review your code before merging it into the main branch. This helps catch errors and improve the quality of your code. Asterisk test your code asterisk write tests to ensure that your code works correctly. Run tests before committing changes. Asterisk use gitignore asterisk exclude unnecessary files from your repository. Asterisk be careful with git reset and git rebase asterisk these commands can rewrite the commit history, which can cause problems for other collaborators. Asterisk communicate effectively asterisk when collaborating with others, communicate clearly about your changes and intentions. Asterisk use a Git GUI, optional tools like Git Kraken, SourceTree, and GitHub Desktop can make Git easier to use, especially for beginners. 18. Troubleshooting common issues. Asterisk error, failed to push some refs to remote_URL. Asterisk this usually means that you have local commits that are not in the remote repository. Pull the latest changes from the remote repository before pushing, git pull origin main. Asterisk merge conflicts. Asterisk see the resolving conflicts section above. Carefully examine the conflicting changes and decide how to resolve them. Asterisk accidentally committing sensitive data. Asterisk if you accidentally commit sensitive data, example API keys, passwords, you can use git filter branch or the BFG repo cleaner to remove the data from the commit history. Warning asterisk this is an advanced operation and should be done with caution. After removing the data, you'll need to force push your changes to the remote repository, which will require coordination with other collaborators. Asterisk losing changes. Asterisk if you accidentally delete a branch or lose changes, you can try to recover them using git reflog. The reflog keeps track of all the changes to your repository, even those that are not committed. Asterisk detached head state. Asterisk this happens when you check out a specific commit hash instead of a branch. To get back to a branch, use git checkout branch_name. This tutorial provides a solid foundation for using Git and GitHub. As you gain more experience, you can explore more advanced features and techniques. Remember to practice regularly and experiment with different commands to solidify your understanding. Good luck.